lazy when I'm loving, I'm lazy when I play. I'm lazy with my girlfriend 1,000 times a day. I'm lazy when I'm speaking.
Okay, we're going to jump to 7.5 now. We're going to do 7.5 in two sections. We'll do one now, and then we'll do the second part of 7.5 where you'd expect it more, which is right after 7.4. Alright, so we've got some word problems to deal with here, and guess what? I'm going to go to the Pre-Calculus 11 video. Okay, so for almost all the word problems, where you're going to be interested in to get your answer is the vertex of the parabola, because the vertex is either going to be the maximum or the minimum point, depending on whether the parabola is facing up or down. And that's usually what you're going to be looking for when you solve one of these questions. You're going to be trying to maximize something, maximize profits, or maximize height. Or you're going to try to minimize something, minimize costs, whatever. Okay, so you're going to try to find the vertex. So one thing you could do is you could, if it's in standard form, then you're in good shape, because anything in standard form, this form, right? It's very, very easy to find the vertex. Just take the opposite of this number and that number there. And then if it's not in standard form, if it's in general form, ax squared plus bx plus c, which most of them will be in, by the way, then what you'd want to use is that formula we used last time, which is that the x value of the vertex is equal to negative b over 2a. So we'll probably be using this for almost every question. Okay, so the first question. A jumping spider, ooh, scary, jumps from a log onto the ground below. Its height in centimeters as a function of time in seconds can be modeled by this equation right here. Okay, and we want to know, what does the h-intercept represent? So first of all, h-intercept and t-intercept is kind of weird, right? Usually we have x and y. So that's okay. Instead of seeing y equals, we have h equals. So we have an h-axis here, and instead of having x's, we have t's, so this is our t-axis there. And as you can see, the first term, the a value is negative, so we know the parabola faces downwards. So I don't know what it looks like. I'm just going to draw something like this. Okay, definitely faces downwards, which means we have a maximum point, and that's good because it talks about maximum right here. What else? So we want to know what the h-intercept represents. Our h-intercept is right here. What's the t value? We don't know how high that is, but what's the t value there? The t value is 0, right? For any y-axis intercept, you put 0 in for the x, or in this case, for any h-intercept, you put 0 in for the t. So if I put 0 into this t and 0 into this t, what do I end up with? 12. So I get the answer 12 centimeters. The h-intercept is 12 centimeters. Now, what is that though? What does that mean? Well, that's the height of the spider when t equals 0. In other words, the very start. Height of spider at the start, I'll say. How can the spider start 12 centimeters in the air? Remember, it is on a log. So the spider's up here on a log, it jumps up in the air, goes a little bit higher, and then it comes down. Okay, the next thing that's asked is, what does the t-intercept or intercepts represent? In this case, there's two of them. There's one here, and there's one here. So what do those represent? This is where h equals 0, right? If they have, for any of these points on this t-axis, the h value is 0. H is 0. Well, h stands for height. This is where the height is 0. In other words, this is where the spider hits the ground. Okay, let's write that down. This is the time when the spider reaches the ground. Nice. Now we're looking at a real life situation here. It actually turns out that some of the stuff on this graph doesn't really make sense. We can get rid of part of this graph. Can you think of what we can get rid of? Well, one thing we can get rid of, I think, is down here. Because what's happening here? Here we have, for all these points down here, we have a height that's below 0. So unless he's jumping into a hole, or I guess jumping into the water or something, I don't think we need to worry about that. The other thing we don't have to worry about is all this stuff over here. Whoops, we don't have to worry about all this over here. How come? Because that's t when the time is negative. We're not interested in the time before the starting time. So really, this is all we need to worry about. It'd be nice if I could draw this blue line in here again. Yeah, this is all we need to worry about. The spider's up here on the log, that's the starting point. It jumps up in the air, hits a maximum, and then it comes down. This is part of the parabola. We don't need to worry about the whole parabola. Alright, when does the spider reach its maximum height? And what is its maximum height? Well, if we're interested in that, what we're interested in is the vertex, right? That'll tell us how high his highest point, and it'll also tell us when he gets that point. That'll be the t amount of the vertex. So all we have to do is find the vertex of this parabola for that equation right there. How should we do it? I would use that little formula we learned last time. The x value, or in this case it's not the x value actually, is it? The t value is equal to negative b over 2a. So what's the b value? The b value is 75, so that means it's negative 75 over 2 times a, which is negative 490. So we get negative 75 over negative 980, and if you put that in your calculator and you round it to 2 decimal places, you get 0.08 seconds. Wow, that's not very long, 0.08 seconds. But if you think about it, the spider's jumping here and he jumps up. How long is it going to be until a spider hits the maximum height? It's not going to be very long, right? It's not going to be like even 2 seconds. Think of a spider jumping. It's not like it goes jump 1001, 1002, now it's going down. No, it's like jump going down, like it hardly goes up at all. So this sounds somewhat reasonable. Okay, now we need to get the y value, because the y value, and this actually it's not the y value, is it? It's the h value, will tell us its highest point. We need the vertex, the h value of that vertex. So there's 2 ways we could do it. We could throw it into that complicated formula, which I don't even know, 4ac minus b squared or something like that. Or we could take this value, the 0.08, and plug it into all the t's here. So I'm going to do that. The y value, which isn't really a y value, it's an h value. So the h value is equal to negative 490 t squared, so 0.08 squared, plus 75 times 0.08 plus 12. And I'm not going to show you, doing that in a calculator. I'm sure you can try it yourself. But when you do that, you're going to get 14.9 centimeters. So the highest point it reaches, this vertex right here, the vertex is 0.08, comma 14.9. The first number is the t number, so that's the time. It's 0.08 after he jumps that he hits that highest point. And the 14.9 is the h value, so that's the height. Now, does that seem reasonable? It says here, back here, that he started at 12 centimeters and he got up to 14.9. That sounds about right. I mean, a spider's not going to jump 30 centimeters up in the air or something. Less than 3 centimeters sounds about right. Starts at 12, jumps up to 14.9, and then comes down. So we've solved this question. Maximum height is 14.9 centimeters. When does the spider reach the maximum height? 0.08 seconds. What is the maximum height? 14.9 centimeters. Alright, that one was nice because they give you the actual equation. But for most of these, they won't give you the equation. So let's try one without the equation. 2 numbers have a difference of 18. The sum of their squares is the minimum. Determine the numbers. Alright, well, what are we trying to find here? We're trying to find a first number, and we're trying to find a second number. We don't know either one of them. Guess what we should call one of them? X. They have a difference of 18. So what could you call the second number? You could call it x minus 18, because one's 18 less than the other. Or you could call it x plus 18, because one's 18 more than the other. Depends whether you want to consider x the small number or the big number. I like x plus 18 here, because I like dealing with pluses and not minuses. Alright, so we've dealt with this first sentence. 2 numbers have a difference of 18. First one's x, second one's x plus 18. The sum of their squares. Sum means add, but what we're adding together is not these 2 things, but the square of those 2 things. So what's the square of x? X squared. What's the square of x plus 18? Not x squared plus 18 squared. That's not right. It's x plus 18 all squared. And whatever, we want that amount to be a minimum. So we're going to see all the possible amounts that this could give us, and we're going to figure out what will make it a minimum. So we're going to get y as small as possible. Alright, let's simplify this. We have y equals x squared plus, x plus 18 squared is the same as x plus 18 times x plus 18, and then you do mountains and valleys. So you get x times x is x squared. X times 18 is 18x, and 18 times x is another 18x. So 18x plus 18x is 36x. And 18 times 18 is 324. Okay, we can simplify this. X squared plus x squared is 2x squared plus the 36x plus the 324. Good. So if we were to graph this, we're not going to, but if we were going to graph this, what would a parabola look like? Would it face up or down? Up, because we have a positive a value. So I don't know what it looks like, but the parabola would face up. In other words, you have a minimum value, and that's great. That's what we're looking for here. We're looking for a minimum. So once we find that vertex right there, we'll have our answer. How are we going to find the vertex? Since it's in general form, I would use that wonderful little formula we learned again. The x value is equal to negative b over 2a. Okay, the b value is 36, so it's a negative 36 over 2 times a, which is 2. So it's negative 36 over 4. It's negative 9. Alright, if you want to get the y value now, which is also useful, we'll talk about that in a second, let's find the y value. Best way to do it, plug negative 9 into these x spots here. So we have 2 and then negative 9 squared plus 36 times negative 9 plus 324. Negative 9 squared is 81 times 2 is 162. 36 times 9 is negative 324, and then plus 324. Well, obviously these two terms are going to cancel, so you're just left with 162. Alright, let's take a look at what we're trying to find. We're trying to find the two numbers. Are these the two numbers, negative 9 and 162? No, they're not. The two numbers are negative 9, we found that one. What's the second number? Well, remember, to get the second number, we do this. We take negative 9 and we add 18. Negative 9 plus 18 is positive 9. So the two numbers are negative 9 and 9. What's this 162? This is the minimum value. We want the sum of their squares to be a minimum. It doesn't ask us for this in this case, but if it said what is the minimum possible, this is the minimum possible value. Not totally clear about that? Well, let's try it. If you squared this number, negative 9 squared is positive 81, and squared this number, 9 times 9 is 81, and got the sum of those two, what would you get? 162, just like we have right there. Okay, so the vertex will give you both pieces of information. Even if they only asked you for the number, it also gives you the actual minimum value, which is very nice. Last one. A rectangular play area is to be bounded by 120 meters of fencing. Determine the maximum area and the dimensions of this rectangle. So this time we have to do both. We have to get the dimensions and the maximum area. Alright, we have a rectangular play area. So let's make a rectangle here. And we need to put fencing around here. And we only have 120 meters of fencing. Okay, well, what do we know first of all? We know that this side here is exactly the same length as that side, and we know this is exactly the same as this side. That's all we know for sure. It's possible that all four are the same, but we can't just assume that. Alright, so why don't we call one of the sides x? Doesn't matter which one. Let's call this one x. Now, if this is x here, how much does this side here, that x side, plus this side here, how much does that add up to? Well, if the whole amount equals 120 all the way around, do you see that this plus this must equal 60? Does that make sense? That's half the way, half of the fencing, so half of 120 is 60, so x plus this equals 60. Alright, so what do we call this one then? If this plus this equals 60, then this one's called 60 minus x. Now, I imagine that confuses a lot of you. So let's check this out. If this one here was 20, let's say, if that one was 20, and these two add up to 60, how much would that one be there? That'd be 40. How do you get that? 60 minus 20. If this one here was 30, what would this one be here? 30. How do you get that? 60 minus 30. If this one here was 10, what would this one be? 50. How do you get that? 60 minus 10. And if this one here is x, which it is, well, we can't put anything here, but look at 60 minus 20, 60 minus 30, 60 minus 10, 60 minus x. I hope that makes sense. This happens all the time in word problems where they'll ask you two numbers add up to a certain amount, call one x and call the other one something else. So for example, if two numbers added up to 52, call one x, the other one's 52 minus x. Two numbers add up to 123, call one x, call the other one 123 minus x. It's one of those little things you just want to memorize because it happens so often. Alright, anyway, let's get back to this. We want to find the maximum area. How do you get area? You multiply length times width. So we're going to multiply 60 times 60 minus x, and we want that amount to be a maximum. So we want this y amount to be as big as possible. Okay, let's simplify. Why don't we do, or expand, I guess. Let's do the mountains there. So y equals x times 60 is 60x. X times negative x is negative x squared. Now, be careful. This is not the a value, is it? No. How come? You have to put it in descending orders of x. So you should actually have y equals negative x squared. Put the x squared first. Then plus 60x. Great. Now if we look at our a value, it's negative. So we know our parabola is going to face down, which means we have a maximum, and that's what we want. So this is looking good. Alright, it's time to find the vertex. Once we find that, we're going to have our answer. So the x value of the vertex is equal to negative b over 2a. b is 60, so negative 60 over 2 times, what's the a value? Negative 1. So you get negative 60 over negative 2, which equals 30. To get the y value, let's take that 30 and plug it into both these spots. So you get negative, now be careful, it's negative 30 squared plus 60 times 30. So 30 squared is 900, and then put the negative on it. So it's negative 900 plus 1800 when you multiply 60 times 30, and if you do that, you get 900, positive 900. So what have we found here? We want to find the maximum area and the dimensions of the rectangle. Are these the dimensions of the rectangle? Is it 30 times 900? No, it's not. X is 30, so we found x. This is 30, which means this side here is 60 minus 30. Well, 60 minus 30 is also 30. So the dimensions are 30, what are we talking about here? Feet, meters, meters. The dimensions are 30 meters by 30 meters. What's the maximum area? Well, there's two ways you could figure that out. You could multiply 30 by 30 and get 900, or you could just look at what the vertex gave you. The vertex told you that the maximum area is 900 meters squared. That vertex is a wonderful thing. When you find that, you've found all the information you need.